working. You guys have every corrupt cop in Rio on your tail. You guys have to move fast.
What's the best route?
Okay, keep going straight another half mile into Rua Fonseca, and then go left.
Spikes ahead, Don. We got spikes.
We're going right.
Nah, it's too tight. We're not gonna fit.
We got no choice now.
The clip that we found for our movie presentation is from the film Fast 5. For context, this video is the scene directly after the main characters rob a bank. Not only did they steal $100 million in cash, they also stole the bank vault that held said cash. This vault is notably being towed by 2 Dodge Charger SRT-8s, which each have a realistic towing capacity of about 1,000 pounds. Each car is attached to the vault by industrial-strength cables. Through this clip, we see the vault being dragged down streets, through buildings, at insane angles, and at extremely high speeds. We selected this clip because there are an array of forces present. The Hollywood dramatization and depiction of physical concepts can definitely become controversial, therefore giving us a lot to say about such a short clip.
The first physics concept we can see in the video is the weight of the vault. The vault is shown to be a large metal box. We can assume it's a strong and likely fortified metal from both previous knowledge of vaults, as well as seeing the battering it is taking as it's being dragged through the streets. Bank vaults are highly secure and hard to physically break into. The vault likely has a large mass, the money inside, about $100 million, adds to the total mass of the vault. Because weight equals mass times gravity, we can assume that the weight is several tons. The next concept in the clip is momentum, which is equal to the mass times the velocity. The mass of the vault stays constant throughout the clip. As the cars drive straight down the street, the velocity of the vault stays constant. As the cars turn, the vault is dragged through several objects, including other cars, stone pillars, and the ground floor of a building. Supposedly, this would decrease the velocity of the vault, in turn changing its momentum. The last concept is friction. The type of friction exhibited in the clip is kinetic friction, because the vault is sliding against the pavement. The vault is sliding in one direction, and the kinetic friction is being applied in the opposite direction. Asphalt is a very rough material that creates a lot of friction with any object sliding against it, no matter the material. So we can assume that there is a large amount of friction being generated.
Another force that is acting during this clip is tension. The cables connecting the vault to the chargers are under tension the entire time, and they are pulling the heavy vault across the street. Without tension present, the scene would not be possible, and towing the vault at all would not be possible.
The physics represented in our clip is not the greatest representation. It ignores real-world physics and represents some of the basic principles in a very unrealistic way. First, the weight of the vault. The vault being dragged through the streets is massive. It weighs several tons, most likely. Typically a vault itself is 10 to 15 tons without all the money that is supposedly in that vault. A pair of cars like that would struggle to pull that much weight, especially at the high speed that they're going. And the acceleration and maneuverability shown in the film really just contradict real-world aspects of physics, because the force required to pull it would be enormous. So as far as momentum and drag, when the cars are moving at those high speeds and making tight turns like they are in the clip, in reality they would be topping over or digging into the asphalt. In the clip it seems that they're just gliding and kind of bouncing around easily. They would also decelerate the cars much more, making it extremely hard to go at the speeds that are being shown. The clip also shows a lack of friction and resistance. Like I said, it was sliding very easily on the road, as if it was like ice rather than asphalt. And in reality, the vault would generate much more friction, potentially creating sparks or, like I said, digging into the pavement. Cables that were pulling the vault should also be tearing up or snapping, especially with the sudden change in direction.